Good morning, my fine friends. Thank you for coming along. Yeah, this is a live stream where I've started it with no ideas about what I'm going to do. Well, I've got a bit of a vague idea. But just before we get into that, instead of the acknowledgement of traditional owners, which I usually do, I'm going to do a quick shout out to... Which button do I press? That one? No, not that one, not that one, that one. To an Aboriginal owned business in Western Australia called Untitled Culture. This is run by three guys who sell ties based on traditional Aboriginal designs. And they look pretty cool, but unfortunately it says sold out of all ties. Now, one thing that I've been looking for. So I came across this particular business because it was in a Twitter thread talking about Aboriginal owned businesses. And I'm often trying to find other businesses and things to highlight. And yeah, if there are any good suggestions, please let me know. So yeah, it is a clever business name, Tied to Culture. Henrik asked, did I modify those 3D printed standoffs? Not since not since the second version that we did. Yes, that's right. So you did see the second one, I think. I can't remember. I don't even remember what was shown. So the last couple of live streams have been me almost entirely ignoring the chat and sitting just there at the bench working on stuff and talking while I was working on it. And so I really like doing that sort of thing. I like working on things and talking about what I'm working on, but the problem is that just the way this is set up right now, it makes it really, really hard for me to interact on the chat, and I miss that. So what I was thinking of doing today was going kind of the opposite, and I'll just go back to sitting here talking to you and interacting on the chat, and we can see where things go, what topics we want to chase, where Steve wants to take us. So good morning to everybody. We've got lots and lots of people here today, and I won't go through the through all of the hellos because there are many. Yes. Oh, Chris says, we like to see you working. It makes me feel better that I don't work at that moment. Okay. Unexpected Maker is setting fire to things. Yes, with the laser stuff. Was it laser controller? Is that what you were working on? I can't remember. There was a project that I saw just recently. Hang on, before I get any further. That is the URL for the Tied to Culture business that I was showing earlier. Right. Is the Superhouse sign still working? Yes, it is. It's just off camera right now because of the camera position. So it is up there on top of... I've got a wall of drawers of components. My little local stock of... No, RMP and toaster oven. Oh, okay, yep. So I often think that if someone just watched one of these streams later and they weren't interacting with it via the chat as well, it would seem like I am being totally random. Like I just said then, oh no, RMP and toaster oven. But that would have come out of the blue, but you wouldn't know what I was talking about. It was because Sion, Unexpected Maker, corrected what I said earlier, and it looks like I'm just saying random things with no context. But if you are trying to, if you are following the chat, then maybe what I'm saying will make more sense. So trying to get it to Reflow production grade SAC 305. Yeah, maybe that is an interesting topic. The whole question of solder paste and what to use Oh, Henrik said you should do more repair stuff one day. What do you think? Yeah, I'd like to do hands-on stuff. But I do want to get the chat. Maybe what I should do is get a tablet or something. I've got a tablet down here which I have been using in the past for changing scenes, and I'm not using that now that I've got the ATEM. So what I could do is take that tablet, put it over there, and have the chat on it. And that way I could read it while I'm working and I've got my hands full. So yeah, SAC 305. In the little bar fridge, which is sort of, you can't see it, but it's down behind me, behind a bench, I've got a collection of different types of solder paste that I've collected over time. Some of it's probably pretty old and I shouldn't be using it, but I've got some, what did I use? I got some GC10, I think, that Game Changer stuff. I've got some Chip Quick. Oh no, the GC10 I think is from Chip Quick, isn't it? I've got a variety of different things. So the one that I normally use, in fact, I can't even remember what I normally use. I'm going to come for a little walk over here and grab out the one that I use. I'll grab out a couple. What's that one? Oh, that's Icavita. Not that one. All right. Oh yes, this Chip Quick stuff. So this is the T4. Yeah, so this is the one that I generally use. This is my current little tub of paste. And it's a leaded Chip Quick paste. So it's a No Clean T4. This is another one. So this is the same stuff, almost, except that it's a T3. And I just wrote the size on the top in marker and Sharpie to make it easier to grab the right tub. So for those of you who don't know, solder paste comes in different grades in terms of the size of the solder balls. And the higher the number, the smaller the balls are. So and the price goes up and the characteristics change. So the cheaper solder pastes are things like T1 and T2, which have quite large solder balls, presumably because it's easier to manufacture. I don't actually know why it's more expensive to go to the final one. But with the lower number, so the larger solder balls, it doesn't work so well with fine pitch parts and like small apertures in the stencil. And for years and years I used the T3 paste, and then a little while ago, because I've been slowly progressing to smaller parts, I suppose, I ended up getting some T4 paste, even though it cost a bit more, and I've just found that it works a whole lot better. So I just use T4 paste all the time now. Like, it goes through the stencil much better. So Sienna asked, leaded or unleaded? Yeah, so this is the question I was getting to. At the moment, this is leaded. So I'm using leaded solder for my own assembly. The Icavita tub that is in there is unleaded, and I've got a couple of other containers in there. In fact, I'm going to go and have another look, because there are some other things in there, and I thought I had, what did I have? Oh yeah, there's another container that is still in the fridge. But what's in this one? Ooh. I got some other stuff to experiment with. This one is Chem Tools SAC 305 lead free. What else have I got? Oh, a few other types. What's this one? Oh, this is a Chip Quick thermally stable. So this one is, these are just little syringes for hand placement. So this is TS391 SNL, which is thermally stable. So in theory, you don't need to keep it in the fridge, although ideally it does make it last a bit longer, which is tin, lead, copper, No Clean T4. So this is a probably a pretty decent one. And this is, hang on, I haven't even opened this. I must have bought this one, stuck it in the container and then forgotten about it. So yeah, it's never been opened. Like it doesn't even have the tip installed on it. This is from Chem Tools, who I think are up in Sydney, and it is a SAC 305 lead-free solder paste. What grade? 05 lot, yeah, don't think it says it on it. I'd have to look up the data sheet for that one. So, yeah, and there are a couple of others in there. But the problem that I have is, yeah, trying to do reflow on lead-free solder paste is pretty horrible. You've got to skirt close to, like, the margin that you have to work with is quite narrow, because the reflow temperature of lead-free solder paste is higher, and the problem is that you'll end up getting closer to the point where you start doing damage to components and to the PCB, and it can become much more critical. So what you need to be able to do is control the temperature within a narrower margin. You need to get it so that it's hot enough to reflow the paste, and not so hot that it melts plastic on connectors and discolors the silk screen on your board and all of that sort of thing. And so I've had problems getting reflow that is within that margin and that is even across the whole surface as well, because it's more important to get a really even heat. Because if you get hot spots, you'll get areas where the solder will reflow, or you'll get a hot spot where the parts of the board will burn and other parts that don't get hot enough, and then the solder won't even reflow. So my experience with lead-free solder in the oven in the past has been that I end up with some parts of the board kind of heat damaged, other parts that haven't flowed properly, and then I have to go in and use the hot air and selectively heat those bits, which is really, really bad. Shouldn't have to do that. Should get it all done in one go. So yeah, yeah. Sion says, your own stuff is leaded. Okay, I only use unleaded now because it's easy to mix up, but I wish we could use leaded. Yeah, and there are issues in terms of being able to sell things as well. So if you sell do I get into this? I don't know. It doesn't seem interesting to me at the moment. Yeah. Oh, Mako has vanilla Coke. Yeah. Sion says, yeah, that's because of your T962C. Not as much of an issue on a proper oven. Yes, that is right. And the other thing is that there are different types of oven. So you can get, some ovens work on infrared and some work, my brain is not really engaged with this subject at the moment, so I'm forgetting the terminology. It's a while since I've looked at this. So as I understand, there are three major types of reflow oven. There is infrared, vapor phase, and what's the terminology for the other one? It's where the air itself is heated rather than using infrared. And the the one that I've got at the moment is infrared, which means that you can end up with hot spots, because if you have, it's essentially using like radiant elements inside it that are emitting infrared all through the thing. So what you end up with is areas that are close to heating elements get more IR, so they get hotter, and you can get heat shadows if you have tall components. All sorts of things can happen. So hot air and vapor phase are the methods that give you a more consistent heating, I think. I may be wrong about that. I'm not even, convection, that's it. Thank you. Yes. So Sion and Keen know more about this stuff than I do. Yeah, Sion says, IR heats up dark parts first and bad hot spots. And that's actually one reason that I'm generally consistent with my PCB silkscreen color as well, because I had to do an assembly job a while ago for a customer who wanted boards done in black, and of course black absorbs heat more, and I ended up burning, like I put a batch of boards in, and one of them actually caught fire because it absorbed so much of the IR that the board heated up, and the fiberglass inside it expanded, like the resin inside it caught fire. There was smoke coming out of the oven. It was really, really bad. So what I want to get is a better oven, and eventually I'll have some space for that, I hope. Right. Yeah, one thing that was really interesting was when I went up to Canberra to pick up the pick and place machines, the Reflow that Glenn was using was vapor phase, and vapor phase reflow is one of those things that I've always thought has been really exotic and expensive and never really even looked into it. And he was saying that because of the kind of work that he does, so yeah, I don't know if I can say what he does, but he does stuff that is like government contract and quite critical, like failure is not not good. So he does lots and lots of layers, like he does like 12 and 14 layer boards, and so he does vapor phase for all of his reflow. So the boards that were made on my pick and place machines were previously going through vapor phase, and I don't really know all that much about it, other than supposedly it gives you really good even results, very predictable and with minimal damage to components and things. So, oh no, Sion says my IN6 oven died. I'm now in the market for a new oven. So sad. Oh, so did it die like in an unrecoverable way? That's really bad. Yeah, the IN6 is one that is at the top of my wish list. I'd really, really like an IN6. I don't have the money or the room right now, but hopefully I'll have the room soon. So yeah, a proper reflow oven is something that I'm going to need once I'm setting up the new lab. Yeah, it won't reflow anything, won't reach or keep temp with any thermal mass. Oh, g'day Aaron. Hey, good to see you. Thanks for coming along. So Sion suggested I buy Sion's and try to fix it. I don't know. I'd be up for that. Sion, do you think it is beyond recovery or repair? Because I am always yeah, I am always up for repairing something to get something cheaper rather than buying it new, which I suppose is to my own detriment. Iggy says, yeah, on Glenn's website, he specializes in FPGA-based communication systems, very expensive and specialized boards to high-end customers, so it needs to be good. Yeah, absolutely. Yeah. Yes. So, Sion says, I'm looking at a desktop vapor phase at the moment. But before you look at vapor phase, check out the price for Gelden. Okay. One question I've got, and something that I don't know about, is the only vapor phase things that I've seen have been desktop type units, like reasonably small. Like the one that Glenn has that he showed me has basically got a lid. You take the lid off, you put your boards in, you close it up, and then you run the cycle. So is it possible to get a vapor phase oven that works with a conveyor belt? I don't know. Maybe the canister has to be sealed, and so a conveyor belt would have to like move boards in and then seal the sides. So it could be a very complicated sort of mechanism to have a a pass-through system. So, ooh, yeah, Sion says you can get commercial conveyor and automated cabinet vapor phase. So expensive. Yeah. I think what I'm going to need to do is possibly the cheapest way out of it. The thing is that once I go beyond my T962, I'm going to need to have a conveyor belt system on it. So at the moment what I've got is a reflow oven, which is a drawer type, but it's basically the biggest drawer type reflow oven that you can get. And the next step beyond that is a conveyor belt system. And I need a conveyor belt so that I'm not manually taking boards out of the end of the pick and place machine, putting them in the drawer, running it, opening the drawer, taking them back out again. I want to be able to have the output from the pick and place machine go straight through the reflow oven and then go out to like an output area, a cooling area. So, Sion is throwing all the URLs at me at the moment. Vacuum reflow soldering systems. Yeah, very big, very expensive. I just saw, is it After Dawn? Hello, this is the first time I've caught you live. Welcome, After Dawn. Hopefully it makes more sense than when you're watching a recording later. Now there was a, oh yeah, so Sion earlier had a link to Mechtronics, which is, oh, what is it? Vapor phase fluid. Gelden vapor phase fluid, 5 kilograms, $1,568. Oh, check this out. So, this is the link that Sion just sent through. I don't know what these different numbers mean. LS215, 200, etc. Call for pricing means there is no way in hell that I can afford it. I can't afford the ones that do have prices on them. So vapor phase fluid, 5 kilos, 1.5 grand. Yeah. Yes. Okay, he says you don't use much, so it's not as bad as it seems. Yeah, it'll probably last a really, really long time. But it is a big capital outlay to be spending $1.5 grand on a few bottles of the fluid to go in the machine. I mean, buying that's the sort of money that I'd have to buy a machine, let alone the fluid that goes in it. So yeah, vapor phase is out of my price range. Very well out of my price range. Okay, so Sion says different density for different paste. Higher density for lead free, lower density for leaded. Yeah. Yes. IBL VAC 7, so Robson says, this is the one I use, IBL VAC 745. So Wagon Load says, does a cooking oven work for reflow? Kinda, but not in terms of like a kitchen oven, because the problem is going to be the temperature control. You need to be able to control the curve through the heat, soak, spike, cool phase. And, oh yeah, Dodgy says, that $1,500 is for the fluid? Yes, it is. Oh, Henrik sent me €2 and said, don't have idea? Go DC and look around, be happy. What? I don't understand. What does go DC mean? Vapor flow phase. So what am I doing? I'm clicking around things. IBL VAC 745 vapor phase. Ah, okay. Hawker Richardson. Yeah, these people make high-end. These sell high-end stuff. Whenever you go looking for high-end surface mount assembly in Australia, Hawker Richardson keeps coming up. They sell like the really big reflow ovens and stuff. So this is a conveyor-based vapor phase soldering oven. This would be ridiculously expensive. That's, you know, showing me something like this. This is like getting someone who drives a Toyota or is in the market for a Toyota, and I don't mean a good Toyota, I mean an old second-hand Toyota, and showing them a Big Addy Veyron. It's DC Discord. It is so far beyond my yeah. I would have a poster of this on the wall. Like back in the 80s, people would have posters of, what would they have? Like a Ferrari 328 or, a Lamborghini Countach or something on the teenage bedroom wall. I think it's a cabinet that goes in and then back out. Oh, okay. That could well be. So load stuff in, it moves in and then comes back out again. Yes. F40, yes. The Ferrari F40 poster. Yes, you can look and you can dream, but never going to own one. That's just the way it is. So, RX-8, yes, I had an RX-8 poster on. Actually, that is a that is one of those weird things. I'd been following the internal Mazda project for years and years after the RX-7 was cancelled, and there was the secret internal project working on the RX-8. I spent years following all the rumors and things around that, and then when the concept images were leaked, and then there was a poster of the RX-8. This is an inline one, okay. Yeah, there was a poster of the RX-8 before it was released. I got that poster of the RX-8, and then years and years later, like many years after it was released, I got a second-hand RX-8. Which was like one of those, I can't believe this is happening moments. I actually got the car that was, that I had the poster on the wall of. And I'm in need of another car at the moment, so I've actually been looking back at RX-8s. The only problem is they are either in really good condition and kind of collector's items, so they're expensive again, or they have done 200,000 Ks without a rebuild, and they're going to explode at any moment, and they've been thrashed their whole lives. So, yes. Ooh, so Outside the Box says, talked to a fellow with a nice RX-8 yesterday. He paid 8K. Yeah, they have gone up dramatically. Dodgy says the RX-8 are ugly compared to the late series RX-7. I don't know. The late series RX-7, like the Athena, the really late RX-7, they are amazing cars. And I've got these memories of them from back when they were current, of how incredible they were. And I've seen, I actually a little while ago went looking and I thought, maybe an RX-7. And firstly, the prices on them are insane. They are real collector's items now. Like the very last model twin turbo RX-7, and yeah, the FD RX-7, and they seem really crude. I know this is a weird thing to say. They were an incredible car of the time, but they just seem really crude now when you look at what they are and how they work. But then that can be a good thing as well, I suppose. Simpler times. Yeah. Yes. Series 6 RX-7 are stupid money. It doesn't make sense. Yeah, it's just because there are so few of them still in existence. I don't suppose there were ever a large number of them, and then they got thrashed, and like the kind of people that buy an RX-7 will thrash it. It's just the way it is. And then you combine that with the rotary engine, like the turbocharged rotary engine, which is under a lot of stress, gets really hot. You get people that that don't take care of them, and so you get apex seals that fail, and then you get catastrophic failure. All sorts of bad things can happen to them, or people that don't keep up the oil to them, so they end up not getting lubrication and bad stuff. Yeah. So, a couple of years ago, a friend of mine had what was it, an RX-4? Yeah, it was an RX-4. And he'd bought it a few years before and ended up selling it. It was a reasonably nice RX-4. It was, I think it had a 13B turbo in it, so it would have been it would have been from a front cut of an RX-7, and like one of the earlier RX-7 13B turbos. And he ended up selling it for, I think it was $57,000 for like a 1974 model RX-4, 1973, something like that. 57 grand. And that was a few years ago that he sold it for that price. Right. So, why am I talking about cars? I don't know how I got on this. Mako got heavy eyes. See you next time. Thanks for coming, Mako. And yeah, talking about cars is probably not what most people are here for. Sorry, on this other screen I am still clicking around reflow ovens. Every now and then I do a hunt around for used reflow. It's even in my search history. Hang on, let's have a look at this. Let's go to there. Yeah, I started typing used R and it popped up with used reflow oven. Used reflow. Yeah, Heller Industries is another place. But finding stuff in Australia is really, really hard because the thing is, I keep coming across ads for things like used reflow ovens in the USA and in Europe. But in Australia, we haven't really had an electronics manufacturing industry for so long that there just isn't the second-hand gear on the market. It's all out of circulation. So finding big, proper, like 5-zone conveyor belt reflow ovens in Australia second-hand, it's impossible. There just aren't any around. And getting them shipped, because the things are so big, getting them shipped from China or wherever, you can end up paying $3 grand just for the shipping. So, yeah. Yes. Pancake says, apparently Steve drives a Mazda. Not anymore. I haven't had a Mazda for a little while. Okay, so Aaron says, I have a technical challenge that requires a value engineered solution if you want something to share some theoretical idea with your experience. That sounds intriguing. So if someone says value engineered, that usually means that it has been designed down to a price. So Aaron, hit us with your question. What is it that you need to be value engineered? How would you have a project or something that you want to make down to a certain price? So Sion says, I think I'm going to need to install 3-phase and then buy an SM Tech RO300 FC and knock out a wall to fit it in. Yeah. Use Reflow. Keep one day. Yeah, all of these sites. Yeah, let's check this out. Like, I'm just going to go for the first one. Just as an example, what is it? $5,300. This would be US dollars, I think. And then, is there a shipping thing on here? Freight. Ooh, available within 14 days in the Russian Federation. Okay. yeah, if you look around places like this for reflow ovens, when I say places like this, I mean like Alibaba and those sorts of things. USD 4,200. I'm just trying to, I'm not looking for anything in particular here. I'm just randomly clicking around ads that come up. So here we go. Look at this. This is up 4, down 4. So this is, it's got 4 zones on this oven, 4 on the top of the PCB, 4 under the PCB. And it is $4,200 and shipping $4,200. So $8,500 by the time you've landed it. And that's US dollars, so that's like more than 10 grand by the time you've landed it in Australia. So yeah, stuff is expensive. What says Amazon has free shipping for orders over $25. Yes. Okay, let's try this. And there's amazon.com.au. Let's try a reflow oven. Oh, they'll have the little ones, like that one. Oh, that's the one that I've got. This largish one here. Okay, Gal. I haven't heard of the brand Gal before. So many of these are just badge engineered, or they're yeah, like these ones all say Gal. That will be someone, that's a company that's either badge engineering it, because I think the originals for these come from Puhui. I don't even know how to pronounce that name. Okay, what do they got? Item weight, 1 kilograms. So this live stream is Reflow Oven Shopping with John. Here we go. I'm not going to say anything out loud because, yeah, she who shall not be named. Add a reflow oven to my shopping list. Anyway, it sounds like both Sion and I are in need of a new reflow oven at the moment. Yeah, Sion says, don't buy a cheap Chinese oven. So, both Sion and I are in need of a reflow oven. And if anyone has any Puhui, yeah. If anyone has any leads, we can fight each other for it. If one good quality used reflow oven comes on the market, Sion and I will end up in a bidding war for it. Does Charm High make reflow ovens? Scott asked. Yeah, they probably catch fire. Right. So, Aaron says, yep, we'll type an explanation. Henrik said, did you see my comment? Yeah, the comment was read Discord, I think, wasn't it? Wasn't that what you wanted me to do? Okay. Discord. I have not opened Discord for a while. This is going to be another nightmare of notifications. I'm just launching it at the moment. I don't know what screen it's going to open. Iggy says, I've already found you the pick and place. I'm not finding you a reflow oven. Yes, I still owe you a finder's fee for the for introducing me to Glenn and finding me those pick and place machines. So, notifications. Yes, my notifications are ridiculous. You should make home weather. Ensures even cheese distribution. Right. Okay, so we've now moved into an episode of Watch John Read Discord. What is going on in Discord? 50 plus new messages. 50 plus just means there's more than 50. It's probably hundreds. Yeah, I'm going to skip through all of that. Oh, there wasn't that much. Okay. All right, so I'm in the general channel. No, I'm not going to sit here and read Discord. What am I doing? This is one of those random. Oh, you should make a home weather station. Okay, Henrik said that. Okay, so it was a different comment. I should make a home weather station. I've done that sort of thing in the past. There is, in fact, there was a. Let me see. Do I have a copy of? Yes, I do. Oh. Here's one I prepared earlier. Somewhere in here is what do I want to switch to? I want to switch to that. So, it's way too zoomed in. What do I want? I think in here, weather station receiver. There we go. Whoops, you can't see it. There. Weather station receiver. Oh, in fact, there are pictures of my RX-8 in here because I've got the vehicle telemetry platform in this book. So, weather station receiver is on page 241. This was a really interesting project, actually. So, this was using a lacrosse weather station. So, this was mounted up on the roof at IVT. That's the view from the roof looking down to the car park. But using an Arduino to, with a receiver module going to an Arduino and intercepting the signal from it. Oh, sourcing versus sinking current. I don't remember writing any of this. It's so long ago. Receiver shield. Oh look, little hand wound antenna. The pictures are so bad in this book. So that is the shield. So this was with a SparkFun. Was it? Yeah, it was a SparkFun prototyping shield with a 433 megahertz receiver module on it and an antenna. This was a pen body. So I got it like a biro or something and pulled the guts out of it and cut it, and I just wrapped some wire around it and put was it araldite or something just to tack the wire in place. So that was the 433 megahertz antenna for the receiver. And then lots and lots of code because this was reading all these pages of explanation of how the source code works, because this was reading the packets of data from the lacrosse weather station and yeah. So what else was there in there? Don't know. Oh, yeah. Oh, and there was a thing about something that my brother-in-law was doing way back then with a weather station to check whether they could do whether it was good weather for gliding. Now, where's the thing about the car? Ah, vehicle telemetry platform. So this is the thing I did in the RX-8. This chapter was huge. Like, this final chapter on the vehicle telemetry platform was a large chunk of the book. It was the most complicated project in the book. Oh, this was Google Earth with vehicle speed plotted around the map. There's a picture of me in the RX-8 with the vehicle telemetry system and parts for it, OBD interface under the RX-8, and pulling data from that as I was driving. Oh yeah, breakdown on some of the parameter IDs in OBD, and messing around with the OBD adapter. GPS. Yep, there was the GPS module in it. Oh, this was a section about design of power supplies for vehicle systems which have really, really bad electrical environment. So there was actually a fair chunk of this was explaining problems with things like load dump in car electrical systems. So like it's pages and pages of explanation. I think that was five 5 pages of explanation of the reasoning behind the design of the power supply in that project. Yeah. So all of this stuff is so much easier to do now than it was back then. Like, I look at the things that we had to do to, like this, the VDIP1 module. So this little module is a USB host adapter so that you can plug in a memory stick, and then what would happen is that as you were driving around, it'd be logging all the data from OBS and from GPS and writing it into a file on the memory stick, and then you could just unplug the memory stick and stick it into a computer. But I had to do it using this little host adapter, and yeah, use this dodgy display. I think it was a 16:2 display. Now I just put a big OLED or something on it, or a touchscreen LCD. Going on and on, more source code explanations. Maybe there isn't a picture of my car in here. No, I suspect not. It's all just pictures of the... No, still going on. Oh, this was memory allocation in AVR microcontrollers. Going on and on and on. Anyway, enough. Looking back at that. Okay. Yeah, Frank said, when did you release the book? Yeah, a long time ago. Yeah. Yes. Oh, Aaron says, check your direct messages in Discord. I've put an explanation in there. Find and share with others for their input and ideas on a solution. Okay, so what I will do is... okay, it's not on screen at the moment. I am going to have a look at the message from Aaron without it being on screen for now. And I will pass on what it is. So... all right, I'll just read it for everybody's benefit. So, looking to create a solution that can be potentially retrofitted to an existing wall-mounted component tray storage units. Hey, I have those. Okay, I think I can see where this is going. The idea is to use a one-wire protocol network to matrix each component tray slot and install a one-wire EEPROM or similar chip component to assign each slot with a unique ID. Then have each component tray fitted with a similar EEPROM to assign each slot with a unique ID. Then have a second one-wire protocol matrix to the same slots that connects to some copper tabs in the bottom of each slot so that when a component tray is inserted, it can be identified in a specific slot. A central DB will then link a slot ID with the inserted tray ID. I've seen some one-wire protocol addressable chips that have 1 or 2 GPIOs, which would allow for the addition of controlling both RGB LEDs in both the slot to identify it and or on each individual tray. The issue is any solution I investigate becomes a problem when factoring in I have 500 trays plus a bill of materials of $5 would soon become a $2,500 project, which isn't feasible. Wanted a solution that is cheap and expandable when you add many trays. Okay, that is a yes. So everybody just have a little think about that problem for a while. What I'm going to do is, I think what I'm going to do, let's see if I can make this so that it only shows that particular message. Okay, I am, yes, hopefully this is okay, Aaron. I'm not going to scroll back or show anything else private. I'm just going to share that particular text on screen. So, people may not be able to read that anyway. Alright, so I need to kind of decode this a little bit and think about what particular problem you're trying to solve. Now, okay. There are a couple of different things here. One is you're talking about using something like LEDs to illuminate specific trays. Now that will be obviously useful for finding something so that you can do a query, database query or whatever. and have it light up the particular thing. So if you're looking for a part, have it highlight and show you where it is. Now that can be achieved without a connection to the individual trays, just by mounting a string of like RGB LEDs or regular LEDs. Probably easiest, the best thing to do would just be to use like WS2812, so that you can run a string of them along and illuminate the section that you want. But there is more to it than that, because you're talking about identifying the individual tray when it is in a slot. And that is a slightly different thing. So, is this because you want to be able to put a tray into a different location and have the system know where that tray is located? And Aaron, before you hit end, just a reminder that this is on screen right now. So whatever you type now, it's going to pop up on screen. Right, got it. So be able to put a tray anywhere and have a system ID it. And Henrik, yes, I saw that. I saw there was a message in Discord General. I will do my best to remember that and get back to it. So what you want is to have a system very similar to what I've got with my plastic boxes, where I have large plastic containers which I can stick on a shelf, and I don't necessarily know which shelf they're on or where they're located, but I want a system to be able to find them. So that's what I'm using the QR codes for. Well, they're not QR codes, they're Aruco codes, which are like spatial markers, fiducial markers. Yes, okay, so you got two things. One is find the location of a tray, and then two is highlight that location. Right, so this is very much like what I did with my tub finder thing, where I've got a string of RGB LEDs along the front of the shelves, and there's a camera on the other side of the room, which is not there right now, with a camera looking at the shelves, and it can find the location of all of the boxes, and then you ask for a specific box and it turns on the RGB LEDs directly under that box so that you can find it. So the thing is that if the trays always go back into the same location, so they have a designated spot, that eliminates the need to identify the trays. But you're specifically asking for a way to identify the trays, which is a different kind of problem. So in terms of cost effectiveness and scaling, oh yeah, and Frank said like Sion's SAM project. Yeah, so that is for, so SAM is for storing pick and place reels, putting them into a certain slot of or a location. And the way that system works, and Sion can correct me if I get this wrong, is that it doesn't sense the reel or identify the reel. When you're looking for a slot, like say you want to store a reel of 10k resistors, you say to SAM, find me a slot for 10k resistors, and it highlights an empty slot, you put the reel in it, and then it knows that's where it is. And then when you ask for them again, it'll highlight that same slot. So it doesn't have a way of actually sensing what's in it. It's working on the basis that it's told you where to put something and you've put it in that right location. So maybe something like that, Aaron, would do the job, because if you're going to have illumination and you've got a tray of a certain thing, you could say to the system, find me an empty slot for this tray, and then it will highlight a slot, you put it in, and then when you want the tray again, it can highlight it and show you where it is. That way you're not having to modify any of the trays. There's nothing smart about them, and you don't get like that really big scaling cost problem. So part of this comes down to size. Now, one of the things that I've become a fan of in recent years is using video processing or image processing to solve a lot of problems rather than using sensors or identifiers. But that only works if the things that you're looking at are big enough, or you can get a good enough image of it to be able to process it. So in the case of, like, I'll just grab one here. Where are we? Back to front camera. So if I just stand up here and grab one of these tubs, like that is a plastic tub. This is tape and string, as you can see. And here it's got the identifying tag. What number is this? And I've got the same on both ends, so it doesn't matter which way I put the tub into the, like up on the shelf, it's the same. This is tag number 119, that one there. And that is an Aruco marker. And so by pointing a camera at this, it can return the X and Y coordinates of this tag within the image. So if you've got a camera in a fixed position looking at a row of these tubs, it can return you a list of all of the coordinates of all of these IDs, and then look up ID 119, it knows that it's tape and string. So if you say, where is the tape and string? It looks up the last known location of 119 in its database, and that gets updated by periodically processing a photo of all of the boxes on the shelves. Now, one of the things that I like about that is that the incremental cost is printing some stickers. So using, in my case, I just use an A4 sheet of sticker material, like an Avery sticker, and then I can just print like a sheet of, how many do I get on a sheet? I don't know, like 40 or something. I just print 40 stickers on the sheet, peel off the next ID, stick it on a box. So the cost is only cents. So Frank says Brady printers use a Dallas chip to ID which print material has been installed, maybe something like that. Yeah, so the Dallas one wire bus, so like the DS, in fact, a lot of people use a Dallas system without even realizing it, because the DS18B20, which is a really, really popular little temperature sensor, it looks like a transistor. It's a TO92 package. They used to be really, really popular for Arduino-based temperature sensing projects, including in things like weather stations. Henrik will get back to it. So in a DS18B20, it is a temperature sensor chip in a package with ground, power, and data. And essentially it's a one-wire bus, and then each device has its own unique ID. And one way to do this is actually just to stick a whole bunch of temperature sensors in there, because the DS18B20, every Dallas one-wire bus chip has a unique ID. In fact, let's have a look at, I'm going to come back to here, Octopart. Let's check out, I haven't looked at Dallas chips for ages. DS18B20, prices are, oh no, that's for encapsulated units. These are the bare ones. What? These prices are, I don't know if this is like chip shortage prices. I wonder, let's go into this one, see if there is any historical information on it. 1 year trend, stock minus 71.69%. Yeah, it's been hit. So it's possible that this is the, yeah, look at that inventory trend. Actually, in a little bit, I'm going to show you an inventory trend, which is, yeah, kind of painful. Yeah, anyway, my point was, any Dallas one-wire bus device has a unique ID. Every single one of them, they're all issued a unique ID. And so what you could do is just get any random Dallas one-wire bus device and stick one in each tray with 3 contacts. You can use a parasitic power mode, but it's not as reliable over long runs, I've found. So I've got a number of DS18B20s distributed around my house, like in the ceiling space and various other places on the ends of long wires. And they do work pretty well. That was what early in my home automation here, I put these DS18B20s all over the place around the house. But this price makes it not really viable. Can we zoom that in? Yes, just to make it a bit easier to read. So what I wonder, okay, so this brings up another question. Maxim, let's go to Maxim. What is the cheapest Maxim one-wire bus device? And I don't even care what it is. Yeah, so DS is Dallas Semiconductor, which was bought by Maxim. I don't even know how to begin searching for this. Let's try... Oh, actually, there is another way you could do it. Using I2C. Oh, okay. Henrik says, look into AliExpress. €3, 10 pieces. Okay. Yeah, there are probably heaps and heaps of clones. Let's try DS18B20. Now, the thing is that you can also use something like a MAC address chip, like a tron.cc macmod. What is that part? This one. Microchip. I don't even know if these are available at the moment. Let's try this. So what I'm looking for here, this is a MAC address chip which is used in, now that pricing is more reasonable. So this is a, the only problem is that, oh no, you can't do that because of the address issue. Oh, damn. Yeah, this is a serial EEPROM, but it's I2C interface. The problem is that you would have to assign a different address to each one of them, so that's no good. All right, that was a dumb idea. Yeah, so 50 pieces for 20 bucks. Yeah, so this is possibly worth investigating. And the side effect is that you would have a temperature sensor in every one of your trays. Oh, what about the paddock chip? What was that one? EV blog featured for 3 cents. AT Tiny with software I2C. Yes, but the problem is that you're limited because I2C only allows you 127 addresses. So that wouldn't really be a solution either. In fact, I wonder how many of these you can have on a bus, like Dallas one-wire bus. How many Dallas one-wire devices can go on a bus? Let's just ask this silly question. One-wire bus. Let's see. Yeah, so you can see there, this is an I button, a Java ring with an embedded I button. Yep. So one-wire buses. So yeah, you can get parts that are just an ID, nothing but an ID. That's what this is, an I button, which is just an identifier. All it does is when you query it, it responds with its ID. Hang on, let's let's improve this readability situation a little. But how many devices can we stick on one-wire bus? Yeah, Yeah, each one-wire chip has a unique identifier code. So, okay, so it's an open drain wire, 3 to 5 volts. Data rates are 16.3 kilobits a second. Okay, so you can drive up to 100 meters. Wow, you wouldn't need that. Binary number 1, yeah, okay. Each device in the bus is a 64-bit serial number. Yeah, but what I want to know is, the thing is that you end up with things like capacitive loading on the bus, and that, that can limit how many devices. Nope. Does anybody know? Go back to Google, there was something. Okay. How long can one wire bus? How many wires? Is it directional? How do you use? How many? Here we go. How many DS18B20 temperature sensors can I connect to one bus? Can I use, for example, 50 sensors? Let's see what the answer is. Come on, Stack Exchange. Second answer, there are limitations. Total length of the bus gets large. 50 meters, you'll suffer from capacity of the cable, reflections. Oh yeah, you can get dedicated driver chips. I just want like some concept. Is it 10? Is it 1,000? Is it, yeah, how many devices? Obviously it's going to vary. It's going to depend on the wiring and the, yeah, and a whole bunch of different things. So, right. Will there be a problem if I use 9 sensors per bus, total 45? No. No, so we don't really have an answer there. Henrik says, I used 2 that worked. Yeah, I've used, I think the most I've had on one bus is about 5. But in imp-enabled, let's try this one. See if there is any answer on this. This is in the Arduino forum. Have you ever heard of, someone asked the question, have you ever heard of Google? Yes. Allowing up to 75 devices to be found per second. Okay, we don't care about speed though. If you can find 25 in a third of a second, 225 in 3 seconds, doesn't mean you can actually have. Yes, exactly. There is no specific limit to the number of devices, electrical issues related to capacitance, etc. All right, let's see if this PDF still exists. It does. All right, reliable one-wire networks. So, Aaron, I think, now what this doesn't do is give you the ability to put an LED inside the particular target device, because this device doesn't drive an LED. But what it does allow you to do is detect the device. So what you could do is have the illumination fixed behind it. If what you're talking about are trays with like the clear component trays, then you can probably illuminate from behind it and you should be able to see. Yeah, well, James says you could also use a rotary hex switch and manually code each draw. Yeah, but then how do you do the connections to it? The idea is that we don't want to have a whole lot of pins on the back of every drawer. We just want a minimal number of connections of ideally 2, maybe 3, like little copper strips or something that mate as the drawer is pushed in. Oh, Wagon Load says, what about a one-wire LED? Yeah, that would be perfect, because then you could illuminate it. In fact, then you wouldn't even need the illumination behind, because all you do is, if you want to illuminate something, you just send out the illumination code for the ID of that particular device. However, there is a slight complication here. So David Jones said 63 peripheral devices. One wire is a single line bidirectional half duplex serial bus to which up to 63 peripheral devices can be connected to a single host. So the way around that is to have multiple one wire buses. And you can easily support it. Like with an Arduino, you can you only need one I/O pin for a one-wire bus. So on something like an Uno, you could have 6 one-wire buses with 63 devices on each bus. It wouldn't be a problem, apart from RAM issues or whatever in the MCU. But with something like an ESP32 or whatever, you could do that. And then you could just divide it up. So on your parts wall with all of the drawers, you could have, you probably want to base it on some sensible multiple. Like say your drawers were 10 wide, you could do 4 rows, say per bus. So you'd have 40 drawers per bus, and then you'd have another bus for the next 40 drawers. So what you would need to be doing is keeping track of when you've got a connection to a particular one-wire bus LED, you would have to know which bus it's connected to. Or you could just send the signal out every bus, brute force it. Yes. Right. So I've never actually seen a one-wire bus LED. So Wagon Load says, look at my suggestion. Can you make a one-wire addressable LED and just call the LED you want? Maybe. Is there a one-wire, let's just search for one-wire LED. One-wire single LED driver. What is this? Looking for a one-wire LED with built-in IC. Would one-wire be fast enough to update 4K LEDs? No. No, we don't care about speed. No. It is APA 102. No, we don't care about any of that. Because the thing is that regular addressable RGB LEDs are not actually addressable. It's just the position in the string, which we don't know. What is this thing? This NXP thing? It says no longer manufactured, but I'm curious anyway. 20 milliamp current source for a single LED that allows standalone blinking of a predefined pattern to offload the microcontroller and save battery power. One wire interface to control the device. Well, that sounds kind of like what you want, but ideally you would want is there a new version of this? Oh, it's just, I know it's out of production, but I'm just looking up pricing. Australia, come on, give me a price. Is there a price on this? Not available. Nope. But something like one of these, if this was available cheaply, this would be excellent because it would give you the unique ID and it would give you the LED. So you would just need power and data going to each of the drawers. So I think that's probably worth worth investigating. One wire. I'm just going to look for one wire LED again. See if there is any. Nah. One wire bus. If you could get something like a one wire transistor, one wire bus transistor, that would be fine as well. So what I would really like is just a list of all of the one wire bus devices. Guide to one wire communication. Now, let's try list of one wire bus devices. I'm kind of fixated on one wire bus at the moment. Serial number button, smart battery monitor. digital thermometer, parasitic power, serial number button. Yep, that's just support from an external thing though. It's not what... Oh, let's see. One wire products from Maxim. Let's see what they've got. I'm not going to read through all of this. Let's try... No, there's no LED transit. No, let's try output. No. So, just to explain my thoughts, what I'm looking for here is something like an N MOSFET transistor with a one-wire bus interface. That would be perfect, because what you would do is you get the ID, and you could use the transistor to switch something, like get it to turn on an LED or make it fire a buzzer or something. Yeah, this, if it was cheap. Oh, Henrik says search fan 5626. Ooh, and Aaron has a suggestion as well. What about this one? It is a... I can't even tell what it is. What does it do? I see LED driver. But what sort of interface does it have? Let's see. Constant current regulator. Where is its interface? Enable pin. Can be PWM'd. No, I don't think this solves your problem, because this is, unless I'm misinterpreting this, this looks like it's just an LED driver. So you need, what have we got? Enable, out, RX, ground. Yeah. So all this is doing is allowing you to supply a constant current source to an LED, but you would still need some way of connecting to it. So, well, yeah. All right. No, that's all right. So Henrik suggested fan 5626. Let's see what this is. I have no idea what this part is. Linear LED 6 channel with single wire interface. Oh, this could be interesting. No, go away. 6 channel current sync linear driver. What is the, where is it? Single wire digital control interface. 32 steps. And it says 34 cents a unit. So Henrik, I think you might be onto something here. I've got no idea what the driver is going to be like. It says single wire digital interface, whatever that is. Can we daisy chain a whole heap of these? Well, not even daisy chain, because daisy chaining, yeah, what I'm talking about is we need a bus type system. We don't want a daisy chain system. So, okay, I'm going to do the thing that I do when I'm feeling lazy in this situation. I search for the part number plus Arduino, and I see if anyone has done anything with it. Okay, oh, must include, nope, 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 doesn't look like it, because that's where a lot of the tutorials and things end up popping up. So, let's have a look at what the interface is on this thing. Is it like a Dallas one-wire bus? So, can we just stick a whole lot of them onto a bus? So I set control. I assume that control is the input. What do we use to talk to it? Does it have like an ID or something? Or is it a situation where you just have one digital pin going to one thing? BN, no, come on. Control pin input current, no. Where is logic input? High, low, control, low, time for dimming. Yes. Oh, see you, Peter. Thanks for coming. But from the external power source, just so far. Oh, okay, digital interface. So is this just like a serial interface, or is it a bus type thing with IDs? I have a feeling that this one does not have an individual ID. So what you need is a single digital pin to talk that protocol. So where is that protocol? Coming back to here. Digital dimming control. Control level. Yeah. I don't think this is going to solve the problem. This is the same thing. It's a driver, and you can control it using a protocol on a single pin, but I don't think you can, it's one directional. There's no ID inside the device. You can't get the ID of the device, have multiples of them on a bus, and then send a command that will only be responded to by that particular thing. All right. So far, this one, oh, hang on. No, not this one. So this is the one that doesn't do it. So far, this one is the closest, but it is no longer in production. So what we want is a one-wire LED driver. Or, failing that, I would say go with the DS18B20, but you know, from this sort of thing. You could experiment with a small number. Okay, so like this. I'm just picking something randomly here. 10 of them for $3.88 with $1.66 shipping. I think, Aaron, I would go down this route. What I would do is just get like a 10 pack or something of these and experiment with them. So what you need is 3 connections to the back of each of the boxes, and yeah, you'd need code that will enroll new boxes into the system, because what you need is some way of being able to tell, you need to, some kind of a lookup table, like ID 123 is 5mm blue LEDs or whatever, you know, whatever it is that you store in that particular component tray. So what you then need is to enroll a box. So you would put a box in and query, and it would say, I have a box with this ID, what label are you going to assign to it? And you put in 5mm blue LEDs or whatever you want. And then later when you say, I want 5mm blue LEDs, it knows the ID of the box and it sends a command it reads from it. Oh, hang on. I'm just thinking about this. This does not solve your location problem. That is a total brain fart moment, because you still don't know which slot it's in. Damn. How do we figure that? Because the thing is that they're all on a bus. So you could have them in any random slot and they'll appear on the bus, but you don't know which slot they're on. Yes. It could be done with multiplexes so that you sequentially address each one. So what you would do is have a connection in the back of each slot with 3 pins. So ground, power, and data. The data pin you would take back to a multiplexer, and your control system would set the multiplexer so that it is going to read from the first slot, and then it would get its ID, and then it would switch to the second slot, get its ID, and it could scan across all of them. So effectively what you would do is you would be having one device on the one wire bus at a time. You were just selecting which device you're talking to. Can a PLE work as an addressable gate? I don't know. Okay, so let's try one wire bus multiplex. Is it plexer or plexor? I don't know. How to multiplex a one wire master into numerous channels. Yes. And you'd want to be able to do this cheaply. So a mux, and then you got the one wire devices. What sort of mux would you use? 4 to 1, 16 to 1, 28 QFN. So you could use, I wonder if you could use stacked muxes. Let's try this one, just because it's got the most pins. Beyond the rail, 16 to 2 multiplexer. Okay, now what is the price on this one? Let's just check out Mouser, because it was the first one that came up. Come on. First one that came up in the search. What's the stock? 4 in stock, 139 in stock. Come on, give me a price. Give me a price. Am I not seeing it? What's going on? Oh, $12? No. Okay, $12 sucks. All right. I'm just going to go back to Discord for a second because I've been getting notifications. Yeah. They're saying they were too expensive. It looks like they are cheap if you go for the clone suppliers. So these things, these won't be genuine. But the thing is that the one wire bus stuff has been around for decades and it's been cloned. I wouldn't have any particular problem with buying these third-party clones. So yeah, 50. If you look at this one, it's $20 for 50 pieces. So, 25 cents. Is that what it works out to? No, 40 cents. I don't know. It's not too expensive anyway. What was that part? I got distracted. So this one, okay, power management IC, PMIC LED drivers. This one, what is the bus on this? PWM? No. Okay. Oh, maybe that was the thing. So Stephen said, could you use an MCP 23017 to drive the VCC lines for your multiplexing? I see what you're saying. So instead of multiplexing the data line, turn off power. The thing is that they may still power up parasitically. So yeah, that's an interesting thought. But I don't know that it would work. You'd have to experiment with that. Yeah. Okay, I am going to go back to general because otherwise I'm going to forget it. So Henrik has been saying, check this out. ThingSpeak channels, this is my weather station data link. It's sadly down for now. Let's see. All right. Looks like we've got, yeah, so temperature 2. That'll be humidity, is my guess. Hitting up to 99% humidity. Ooh. What's this one? Meters per second, so that'll be wind speed. This one, Sund. I don't know what Sund is. What's this one? HPA, hectopascal, so that is atmospheric pressure. And this one, Luxides, Lux, that'll be illumination, is my guess. Or is it UV? That could be like UV rating or something. Unless this looks like it corresponds with days though. So goes up during the day, down at night, up during the day, down at night, then there was a downtime. So either lux, like sun brightness, or UV. Yeah, cool. Thanks, Henrik. All right. Oh, Henrik said, sorry, it's in Estonian language. Yeah, that's okay. Just lux. Yeah, brightness. Yes. So Celtic Beast asked a good question, which is, can you get the address from out of addressable LEDs? Can you use them for address and visualization of position, or they don't have individual addresses? The short answer is no, they don't have individual addresses. The way they work, like when we talk about addressable LEDs, like the DS18B20 or yeah, that sort of thing, the way those devices work is that it's a bit like a shift register, where you have a, I'm going to do lots of hand waving. I should be able to describe this a little bit better. Let's do slightly less hand waving and slightly more of drawing. Looks very dark on that camera. I need more illumination here. What am I looking for? I'm looking for a pen, that's right. Okay, so the way, trying to get this into the right position. Where's my hand in relation to the screen? There, MCU. And then you can see all that? Yep, okay. So what happens is, the way these so-called addressable LEDs work is they have an in and an out. In, out. So it's data in, data out. In and out. Now there are complications to this. I don't know if I'll get into it, but anyway, so we have a data pin. So say we have a GPIO here, and it is connected to the in there, and then the out on this one is connected to the in on the next, and so on. So we have a sequence of them, and then these are the LEDs. And of course they have power connections, but I'm not even going to show those for now because they're not really relevant. So what we have is data that comes from your microcontroller, and it goes into the chain. Now the microcontroller, and it's one way. There is no way to get data back from it. Data only ever goes this way. And so what happens is that you send a frame of data. I'm going over in my head how to represent this. I'm not even sure the best way. But say you have a frame of data and I mean this is, and you want to send values for 3 LEDs because you know that you have 3 LEDs in the chain. So what you do is you send a chunk of data, which is the color, one set of colors, another set of colors, another set of colors, and excuse me, hang on, I need a drink. Also, the disclaimer is this is not necessarily accurate. This is just conceptual. So say you want to send a string of colors and you want to set this first one to red, this second LED to green, and this third LED to blue. What you do is you send a chunk of data and it's got the RGB code for red, and then the next one has the RGB code for green, and the next one has the RGB code for blue. And you send that data out of your microcontroller port into the first device. But the microcontroller actually has no idea what's out here. All it's doing is sending this big chunk of data. The red LED, or the first LED, reads this big packet and it goes, oh look, I've got this chunk of data. I am going to take the first instruction off it, which is the red, and I'm going to set myself to red. And then it strips off that front part and it sends this chunk of data on. So here we have a chunk of data which has the code for blue and green, which comes out of this and it goes into the next one. And this LED says, oh look, the first part of this is green. So I'm going to set myself to green and send on a packet of data and just pass the rest of it through. So what the third one sees, oh look, the first chunk is blue. I'm going to set myself to blue. And there's nothing else to pass on. So if you had a fourth LED hanging off here, and you had sent the data to set 3 LEDs in turn to red, green, and blue, you would get red, green, blue, and then nothing, because there's no data left to come out the end. So when you have a long string of addressable LEDs, what you're doing is sending out a frame of data which specifies in sequence what you want each of those LEDs to be. And that's how the data spreads down the chain. But you can't say, for example, I want LED 3 to go orange and leave everything else the same. You have to resend the entire frame, including the values for these ones. You can't just send, I want a frame that says orange and I want to send it to the third location. You have to recreate your whole frame and make that, oh, not that one would still be red. Make that one orange, resend your whole frame. This one was red, it's still red. This one was green, it's still green. This one was blue, now it's orange, so it changes color. So that is the very simplistic and not necessarily technically correct explanation of the way the RGB LEDs work, but there are complications. There are variations on that as well. In recent years, there have been some extensions to that very simplistic scheme. There are LEDs you can get now that are kind of fail-safe, because what happens is if you have one LED in a long string die, it will then fail to pass the data on to the next. And so what happens is that the LED string will die at the point where one of them dies. The rest of the LEDs just stop working. So there are more modern replacements of the WS2812, WS2813 that have like pass-through data as well. So even if one element dies, the rest of the message still gets passed through to the next element. And there is yeah, I don't actually know how this works, but recently I've been seeing reports of people who have bought LED string and then cut it. Because normally what happens is if you get a string of, say, 100 LEDs and you cut it into 2 lots of 50, when you feed data into the first one, you can set 50 different items to the color. The second string, it's like you've reset the address because it's just based on its position in the string. And so that thing that I was just describing to you with that little diagram is kind of how you expect things to work. There has been some really weird behavior. I've seen a few people posting on Twitter saying that they have bought addressable RGB LED strip and cut it, and the individual LEDs seem to remember their position within the strip. So if you got a strip of 100 LEDs and you cut it in half, and then you take the second half and you start feeding data into it, it doesn't start at address 1 anymore. It starts, like, it doesn't go back to address 1. It starts from address 51. And that is kind of a bit of a head scratcher. So I don't really know much more about that, but I've been hearing some people reporting weird behavior. Now, what is an RGB driver? Ooh, okay. So Angry Telstra Man and Maina have been putting a few things in, yeah, there have been quite a few things posted in Discord. There is, I might as well bring this up so you can see what I'm looking at. Okay. Come on, why can't I scroll? I don't know. Yeah, so we've got one-wire LEDs, an RGB LED driver on a modified one-wire bus. There is the FindyBot 3000, the voice-controlled organizer. Yep, I saw that one on YouTube a little while ago. DIY or Die, how to store and organize electronic parts. And Chip Easy, Smart Electronic Component Organizer by 3D Facture. Okay, yeah, so there are quite a few people who have tried to solve this problem. Robson says, Adafruit sell these LEDs, they are burning with a set address from the factory. Yes. Yeah. That's interesting. So Robson says, Adafruit sell these LEDs. Let's see if I can find those. Because that could just be the solution to the whole thing. LED, Adafruit, fixed address LED. I don't know. Let's see what this one says. Fixed address, NeoPixel fairy lights. Yes. They don't function like NeoPixel. Yeah, so technically a NeoPixel is an LED that also acts as a shift register. Yeah, so this is what I was just trying to explain in my fairly bad way. So what they say here, 24 or 32 bits of brightness data comes in on the input pin, the LED removes it and passes along the rest. Yeah, so it just takes the first chunk of it, applies it to itself and then passes the rest along the chain. But these ones are different. Each LED in the strand is addressed from 0 to 100. You can't chain two of these and expect that the strip will extend. Also, if you cut this in half and connect the data line to the two halves to the microcontroller data pin, it will still act as if it was one long strand. This would be super, super useful. And I have a feeling that this might solve your problem, Aaron, because with this, you don't actually need to know the location of the... oh yeah, so Robson says they only come on a small string. Yeah, with this you don't need to know the location of the box. All you need to know is the ID. And then you can illuminate that particular ID. Now where is the middle wire is data, the remaining wire is ground. So is it only 3 pins on the things themselves? You know, multiple branches. Yeah. Yeah, so what this would not allow you to do is query where is the location of a particular tray. But you could send a command saying illuminate this particular tray. It's a limitation though that there are only 100 addresses. What you would really want is more, because if you have, say, addresses 1 to 100, and then you have a second set of trays which you bought another one of these light strips and that was also address 1 to 100, you couldn't distinguish between them. So that's a bit of a scaling problem. Yeah. Hey Gerald, thanks for coming. Okay, yeah, this, if you could get this in like 1,000 long string with 1,000 separate addresses, that would be fantastic. Yep. So, where to from here? Oh, well, you've got some options. Either this with multiplexers or addressable LEDs, like fixed address LEDs. Back to reflow ovens. So, what else should we talk about in the last few minutes? Wagon Load says address each bank of LEDs. Yeah, but the problem is you could use any multiplexer or mux with this to use more. Yes, but only if you had a bank of, say, 100 slots for your trays, and those trays stay within those 100 slots, and they don't go into another set of 100. Yeah. So you could drive multiple chains of those LEDs. That's not a problem. But the thing is that if you bought, okay, imagine this: you bought 2 of these strings of 100 LEDs each, and you chop them up into individual LEDs and attach the LED inside one of the trays with the connections, and you have that tray is now ID number 1. But then you've got the second string of LEDs that you also cut up, and there will also be an ID 1 in there. So you'll end up with 2 trays that have ID 1, and they will both illuminate if you say turn on tray number 1. So what you would need to do is have banks of trays and keep them within the bank, not have them migrate between banks, even with multiplexing and things. So, 2 LEDs on each drawer. You're thinking of some kind of an addressing system. Do a combination. Yeah, you'd need an AND gate type arrangement. What you'd end up with is illuminating, you'd have 1 LED illuminate on every drawer with ID 25, 1 LED with ID 16, and 2 LEDs on the drawer that has both 25 and 16 in it. So I don't think that would entirely solve the problem either. My brain is fading. It's really, really fading. Interesting. So, Pancake Legend said, I recall Tubular using a strip of WS2812 to detect light and identify its location along the strip. Yes, he told me about that just recently. So, for those of you who don't know the matching between the handles here in the chat and real life names, Pancake Legend is Andrew from the local hackerspace, and Tubular is Lachlan, who has the factory that I'm going to be moving into. And so in his factory, one of the things that he set up as a bit of an experiment, like a thing he was playing with, is he got some stuff that is like core flute. How do I describe core flute if you don't know it? Think of it as being like cardboard, like corrugated cardboard, but made out of plastic. So it's got long channels through it, and he's got LED strip inserted into it so that it can glow from the inside. And he was detecting positions of things using the LEDs. Fred Flintstone says, you could just label the drawer. Yes. So Dodgy asked, how is the plan to move going? So moving into Tubular / Lachlan's factory space, it's still a bit of a waiting game from my side. So he's continued to do some clearing up, and There is lots of floor space visible now, which there wasn't when I first went and checked it out. But there's still quite a lot of stuff in the front room. There's still quite a bit of stuff to move out of the back mechanical area, like the factory area. I have paint for the floor. I went out and bought some paving paint, so I'm ready to put that down on the floor as soon as the floor is all clear. And we still need to do the carpentry to rebuild the wall in between the front office and the factory area. And maybe we will get to that soon. So it's getting towards that it's kind of heading towards that crossover area. At the moment, I'm trying to stay out of Lachlan's way and not push him too much. I would like to have access to it today so I can get in and start fitting it out. But I also don't want to be on his case saying, is it done yet? Is it done yet? And there is a certain point where his cleaning up will taper off and my fitting out will taper up, taper on. So, and there is a little bit of a grey area for that, like what is his responsibility versus what is my responsibility. There are certain things that are very clearly my responsibility. For example, painting the floor and building the walls and the ceiling for the clean room and fitting all of that out. And then there are areas that are slightly more grey, like there is a dividing wall in between, in fact, I'm going to dox myself, I think. Yes, I'm going to dox myself, but I'm going to pull this off the screen first and go into a design. Where am I going to go? Because I don't want to dox my home address. All right. I will only dox the the factory address, which is going to be public information anyway, so that's not such a problem. All right. So this is doxing the factory address. I could rename the project so that it's anonymized, but anyway. So this is the overall factory space, approximately, kind of give or take. And the area that you can see where it's got all the stuff in it, that is the bit that I'm going to be fitting out. And this wall right here is currently a big mess because it had termites in it. So Lachlan has stripped off the plaster on this top side of it. It is all just exposed frame, and he's also pulled out a whole lot of the timbers that are in here. And there is where these two doors are shown here on the plan, that is now just a big hole. It's all been chopped out. You can walk straight through here between these two rooms. No doors or anything. Not even door frames. It's just a big hole in the wall. So it's getting to the point where there is the question. So yeah, what I'm talking about is this wall right here. It's getting to the question of at what point does Lachlan stop working on this and I start working on it. And it's, oops. Yeah, I need to have a chat to him about that because, I mean, it'd be good if he did everything, but then that's also not fair on him having to do everything. So at some point I need to take over all of this work and begin doing the fit out. So there's going to be the question of, does he install these doors? Do I install these doors? Do I rebuild this wall or does he do it, etc.? So yeah, at the moment the current state is this. Now, how can I drag this? There we go. So this area at the back, which is going to become the clean room, the floor in here is pretty much clear. There are still a couple of benches and things on wheels that are just sitting in this area, but they're easily moved. They're not fixed equipment. So that can just be rolled out of the way at any time. So it's almost at the point where I could get in and paint the floor in this part if I wanted to. I'd also need to clear this wall and strip it back. There's old plasterboard and stuff on there. There's a tool pegboard on there. All of that will need to go, and then paint the wall. But there is still a whole lot of stuff all down this side, this wall here. There is all the way along here. There are shelves and bits of steel and old equipment. There's old equipment sitting around in here that needs to be moved out. And in the front room, there are still shelves and odds and ends of things. Like this whole wall here is currently shelves with electronics magazines in them. So they need to be removed. And there's other stuff in here as well. So it's getting close to the point. Oh, and then when this room is empty, all of the flooring has to be ripped up because it's got really old carpet in it. It's probably been in there for 30 or 40 years. So this is going to have to be ripped up back to the concrete floor and then new flooring put in. Yeah, anyway, that's the general plan. And hopefully getting close to being able to do it. So yeah, I need to discuss that with Lachlan and find out what point he feels comfortable with me taking over all of this. Yeah. I am gonna go, I think. Oh, hang on. What I see is an RFID tag. Does that have a unique address? Does it need to be powered via RF? Could it be hacked to use wires? I know where you're going with this thought process, but that is a really complicated subject. You can do RFID with passive. So yeah, in fact, Lachlan has printed some RFID tags. So what you can do is the really, really cheap RFID tags are actually just printed. Like they're not active electronics in the way you would think of active electronics. They don't even have a chip in them at all. It is a very clever structure on, which is like a coil made out of, you can make an RFID chip that will work with nothing but a piece of foil just cut accurately in a certain shape. And what it does is it responds when it's energized by a field at the right frequency. It causes that field to be modulated, and that modulation can then be detected by the RFID reader, which is generating the field in the first place. So that's the way that the really, really cheap printed tags are made. So the tags that go into products and those sorts of things, a lot of the time you can do those, and they're actually just a sticker with a shape on them that has been printed. But the more complicated ones, particularly the active tags, do have chips in them, yes. And certainly the ones that can be reprogrammed. So the thing is that RFID is it's an enormous field with lots and lots of different technologies. It's not one specific technology. And so there are definitely RFID related technologies that could be used in this, it could be used in the thing that you're talking about. And this is opening a can of worms. It's not really a subject to begin talking about it. Oh, look, it's 12 o'clock. Yep. Yeah, Frank says the old tags used a coil and a capacitor. Yeah. All these things are buzzing around in my head. I've seen so many different, because I've been messing around with RFID for a long time now, I've seen many, many different aspects to it. And there was one demo that I saw a company do a while ago where they basically had, their goal was to identify sheets of paper in a stack that had been put down on a desk. And so what they did was have a super low cost printed RFID tag on each sheet of paper. And so I actually saw this demonstration working. What they did was have like a bundle of paper, and they just put the bundle down on the desk, and the computer reads all of the RFID tags in that stack of paper, and it can return your list and say what sheets of paper you've just put down on the desk. So there are all sorts of complications with that. That raises issues of discrimination. So the term discrimination in the context of RFID is being able to differentiate between multiple tags within the reader field. So that is something that a lot of systems can't do. And if you have a reader and you introduce two RFID tags into the field, it can have trouble talking to them. So multi-tag discrimination allows you to introduce a number of tags and query them all and be able to identify them individually. So that is something that is it's kind of hard to do. It's harder than just reading from a single tag that's brought into the field of a reader. And so yeah. Oh, Joel says, yeah, I saw that system for IDing paperwork. It was very expensive for the stickers. Yeah, and I think that is because of the complication of the of it needing to be a multi-tag discriminating system, not just reading a single tag at a time. Anyway, yes. So, interpreting your question, Aaron, reading a little bit more into it. Where I think you're going with that question is, do RFID tags contain a cheap chip which has an ID in it, which will respond with its ID when you query it? And the short answer is, in many cases, yes. The follow-on from that is, can you take that cheap chip and communicate with it electrically instead of via RF? And the answer to that is, I don't know, but probably not easily. It would take a fair bit of engineering and a lot of data on the specific chip to be able to figure that out. So there are different types of ID chips, like there's, and the thing is that in order to be really economical, typically what these chips do is integrate everything into a single device. So if you're looking at something like I'm trying to think of the part numbers. This is from like a decade ago. Was it an EM4001? There are some different chips that are used in the identification tags. Like if you look at pet identification, like the implantable tags that are used in dogs and cats and things like that, the chip itself incorporates everything. It's got the receiver for the RF, so it's got a tuned circuit that is attached to the antenna, typically a coil antenna, which is excited by the radio frequency field at the specific frequency, which generates energy across the coil, and that then powers up the chip, and it allows it to enter its active phase, where it applies modulation to its own receive coil, which then causes changes in the field that is being generated by the reader. So it's not done by like an RF front end and then an ID chip which is attached to it. It's all integrated into a single chip that does everything. So I think it would be a real long shot to be able to take a chip like that and operate it in a way where you are hardwired to it and not using the RF front end. So yeah, I don't think that's I know where your mind is going with that, but I don't think that is going to be a viable way to solve this unless you're putting in a lot of engineering time and effort. EM4305 is the rewritable chips, yeah. EM4100 or EM4200, cool, thanks Joel. Yeah, this is so many years since I've looked at this that I, yeah, I'm having trouble remembering the part numbers and things. Cabletti says there are passive RFID chips that have GPIO outputs. Yeah, that's right. I think you mentioned this on a previous one, and I would love to see one. Like, that would be a really, really interesting thing. Joel says, yeah, you want the EM4100 with an LED driver. Yes, that would be cool. Yeah. Okay. Well, this has been a different live stream to the last couple. But I need to take a break now. My brain is pretty fried today. I woke up with a fried brain and I still have a fried brain. But thank you very much for coming along to have a chat and for the interesting questions and things. It would, yes, as Cable Tie says, it's lunchtime. And yeah, Outside the Box says, I like the style of stream. Yeah, I like talking about things. What I've been thinking of doing is maybe doing some different streams at different times. Like on these streams, doing this sort of Q&A, chatting about things sort of thing. And then maybe at other times, like in the evening, when I'm working on something, I'll just start streaming while I'm working on it. Because a lot of the time I will be here working on something and I could be streaming at the same time. And yes, it slows me down, but it's still kind of interesting. So, thanks for coming along, and I hope you all are having a great weekend so far and continue to have a great weekend. And now that I've opened Discord again for the first time in a while, I will try to catch up on some messages in there. And I will see you all really soon. Thanks. Bye.